June 30th, 1908, Siberia, Russia, 7:17 a.m. A fireball streaks across the sky, brighter than the sun. Then, an explosion. 1,000 times more powerful than the atomic bomb dropped on Hiroshima. It flattens 80 million trees across over 2,000 square kilometers. The shockwave circles the Earth not once, but twice. But when scientists finally reach the remote site years later, there's no crater, no debris, nothing. What really caused the Tunguska Event? This is the story of the largest impact event in recorded history. It took place in one of the most remote places on Earth, the Podkamennaya Tunguska River Valley in central Siberia. This vast, sparsely populated wilderness was home primarily to indigenous and Wanki people, living traditional lives as hunters and reindeer herders. For them, the morning of June 30th, 1908, began like any other, but around 7:17 a.m. local time, the sky exploded. Witnesses up to 65 kilometers away saw a massive blue-white fireball blaze across the sky. It grew brighter and larger until it detonated with unimaginable force. The sound of the explosion was heard over 1,000 kilometers away. The shockwave knocked people off their feet 65 kilometers from the blast and shattered windows in towns over 400 kilometers distant. Eyewitnesses described a wave of intense heat, with one man reporting his shirt felt like it was on fire, even at that great distance. The seismic shock was detected by seismographs across Europe and Asia, as far away as England. Initially mistaken for an earthquake, the readings revealed a different signature, that of a massive explosion, not tectonic activity. Incredibly, atmospheric pressure waves circled the entire globe, twice, registered by barographs worldwide. For several nights following the event, the sky over Europe and Western Russia glowed with an eerie light, bright enough to read a newspaper at midnight in London, nearly 6,500 kilometers away. This strange luminescence persisted for weeks. Despite the global scale of the event, the Tunguska region was so remote and inaccessible that no scientific expedition managed to reach it for 19 years. World War I, the Russian Revolution, and the ensuing political chaos all delayed the investigation. It was until 1927 that Soviet scientist Leonid Kulik led the first expedition into the heart of the mystery. What he and his team found was beyond comprehension. Kulik's expedition arrived to a scene of apocalyptic devastation. Millions of trees were flattened, lying on the ground in a radial pattern, all pointing away from a central location. The epicenter of the destruction covered an area of about 2,150 square kilometers, with an estimated 80 million trees destroyed. Some were snapped in half, others uprooted completely, all lying in eerie parallel formation, pointing away from the blast center. But the strangest discovery was at the very epicenter. Here, the trees were still standing. They were stripped of their branches, scorched and dead, but remained vertical. This phenomenon is known as a telegraph pole forest. The trees directly below the explosion stayed upright because the blast wave came from above, pushing downward and then outward, not from a ground-level impact. This proved one critical fact. Whatever exploded, it did so in the air, not on contact with the ground. Kulik searched relentlessly for an impact crater and for meteorite fragments, any physical evidence of the object. He found nothing. No crater, no significant debris. The explosion had to be an airburst, detonating at an altitude estimated between 5 to 10 kilometers above the ground. This explained the strange pattern of destruction, the standing trees at the center, and the lack of an impact site. But it left the biggest question unanswered. What exploded? The leading scientific theory today is that the Tunguska event was caused by a meteoroid or a small comet. Scientists believe an object, perhaps 50 to 60 meters in diameter, entered Earth's atmosphere at an incredible speed, around 100,000 kilometers per hour. The immense pressure and friction from its passage through the air caused it to heat up, fracture, and then explode in a cataclysmic airburst. The object likely vaporized completely in the blast, which is why no large fragments have ever been found. This theory aligns with all the evidence. The airburst explains the lack of a crater, the pattern of fallen trees, and the immense energy released. The fine dust and ice particles from a disintegrated comet or stony meteoroid thrown into the upper atmosphere would also explain the glowing night skies observed for weeks after the event. Tiny spherules of molten rock, rich in nickel and iridium elements common in asteroids but rare on Earth's surface, have since been found in the soil, further supporting the cosmic impact theory. Over the years, the mystery of Tunguska has fueled many other theories, some far more imaginative. Speculation has ranged from a natural gas explosion to a miniature black hole passing through the Earth. Others have proposed more exotic ideas, like an antimatter collision or even the crash of an alien spacecraft. These ideas capture the imagination, but they lack the scientific evidence that supports the meteoroid airburst hypothesis. There is no radiation, no exotic materials, and no other physical evidence to suggest anything other than a natural, cosmic event. So, why does the Tunguska event still matter today? Because it serves as a stark reminder of the potential threat from near-Earth objects. An event of this magnitude happening over a major city like New York or Tokyo would be catastrophic, causing millions of casualties and unimaginable destruction. It wouldn't just be a local disaster, it would be a global crisis. Tunguska was a wake-up call from the cosmos. Today, space agencies like NASA and ESA run planetary defense programs, actively scanning the skies to detect and track asteroids and comets that could pose a threat to our planet. By identifying these objects early, scientists hope to develop methods to deflect them, should one ever be on a collision course with Earth. Technologies like kinetic impactors, gravity tractors, and even laser ablation are being researched to give us a fighting chance to prevent a future Tunguska-scale event from striking a populated area. The silent, flattened forests of Siberia are more than just a historical curiosity. They are a monument to the immense power of the universe and a testament to our own vulnerability. They remind us that the sky above is not just empty space, but a dynamic environment where cosmic events can have profound consequences. For life on Earth, the mystery that Leonid Kulik first encountered has largely been solved, but the lesson it teaches is one we must never forget. The universe is a powerful place, and it's our responsibility to understand it and protect our place within it. Thank you for watching. If you found this journey into the Tunguska mystery fascinating, please like, share, and subscribe for more deep dives into the biggest questions of science and history. Let us know in the comments what other cosmic mysteries you'd like us to explore next. Until then, keep looking up.